In some distant galaxies, astronomers are now finding evidence that space and time are being shattered by eruptions so vast they boggle the mind. We are just beginning to understand the impact these outbursts have had on the universe, on the shapes of galaxies, the spread of elements that make up stars and planets, and ultimately, the very existence of Earth. The discovery of what causes these eruptions has led to a new understanding of cosmic history. A team operating at the Subaru Observatory atop Hawaii's Mauna Kea volcano examined one of the deepest galaxies known, whose light has taken nearly 13 billion years to reach us. It was a messenger from a time not long after the universe was born. This object is known as a quasar, short for quasi-stellar radio source. A small region in its center is so bright that astronomers believe its light is coming not from a collection of stars, but from a single object of at least 1 billion times the mass of our Sun. This beacon is generated by gas falling onto the object and heating up to extreme temperatures. The only thing known to generate this much power is a swirling cauldron where space suddenly turns dark as it merges into a giant black hole. For astronomers, the question was, how did this black hole get so big so early in the history of the universe? It likely got its start in an early generation of stars, often known as population 3 stars. Made up of hydrogen, they are thought to have been hundreds of times the mass of the Sun. These giant stars burned hot and fast and died young. The first generations of stars and black holes burst onto the cosmic scene in a time of incredible turbulence. Within primordial gas clouds, stars were being born in dense knots. They gave rise to black holes that began to swallow more and more matter. A computer simulation of the early universe shows just how quickly these voracious monsters were able to grow. The project, by scientists at Carnegie Mellon University, was designed to recreate a region in the early universe that measured over 100 million light-years on a side. It shows what took place in the first 1 billion years of cosmic history. This virtual universe is set in motion by equations describing the properties of gas, the energy released in starbirth, and the outward motion of time and space. The result? An intricate cosmic web, with gravity drawing matter into filaments and knots, like a vast tangle of interconnected spiders' webs. Inside the densest regions is where the largest galaxies and black holes grew. Here, circles indicate the appearance of black holes deep in the data. As they gain weight by eating up their surroundings, the circles grow larger. A few in the largest galaxies reach ultra-massive proportions, billions of times the mass of the Sun. To learn what allows them to merge, we go back to the ideas developed by Albert Einstein. He said that when massive bodies accelerate or whip around each other, they literally disturb the fabric of space, causing it to ripple like a disturbance on a pond. When these ripples move outward, they carry with them the energy of the pair's orbit, causing them to spiral closer. When this dance of death comes to an end, that's when the pair joins together to form a larger black hole. That moment may be approaching for a quasar called OJ-287 at 3.5 billion light-years away. Flare-ups in the surrounding region have led astrophysicists to conclude that another black hole is flying around it. By measuring the giant's gravitational hold on its companion, astronomers estimate its mass at 18 billion solar masses. For a time, OJ-287 was the largest black hole ever detected. It no longer is. Deep in the heart of the Coma Galaxy cluster, a mere 321 million light-years away, lies a giant elliptical galaxy known as NGC 4889. Astronomers used several large telescopes to measure the speed at which stars are orbiting around the center. They used that data to calculate the mass of the central object. A whopping 21 billion solar masses, give or take a few billion. Theoretically, there are no limits to how much weight a black hole can gain. The largest black holes in the universe probably rose between 10 and 12 billion years ago, the age of the quasars. In X-rays, you can see a jet erupting from the center. Peering through the dense dust lanes that dominate our line of sight, astronomers have come to believe that it's actually two galaxies in the act of colliding. This computer simulation shows the effect of such a merger on black holes. As the two galaxies pass by each other, the pull of gravity disrupts their spiral shapes, forcing huge volumes of gas into their cores. As the black holes begin to feed, they emit blast waves that push much of the loose gas out beyond the boundaries of the new galaxy. In the final steps of this cosmic dance, the two black holes merge and emit one final blast. To think that our Earth, our solar system, ourselves, are the beneficiaries of these faraway monsters.